All right, let's go and look at your homework. So we have 5.1. I don't know why this isn't writing. And they give you these two different flow rates. So they give you, say for example, 110 cubic meters per hour at 6 a.m. Definitely in need of a new stylus. And then the flow rate increases to 280 cubic meters per hour at 9 a.m. And they ask you to find a left estimate, a right estimate, and the best estimate. Or I guess they don't ask you to find the left and the right, you just know you have to be able to find the best estimate, you take the average. So what you're multiplying then here is this difference here, can't get anything to write, is 3 times this first one would be your left estimate, and then your right estimate would again be your width, your time interval, times 280, and then you divide by 2 just because you're taking the average. And that was number 11. Wow, this is really not writing. I'm not sure why. Let's try it this way. Okay, so that's number 11. Number 12 is what you guys did in class. That's your quiz. So if you need help with that, I actually have that recorded in the quiz folder. Number 16, I also did in class. This is where the car one, where you end up with 2 triangles. So ultimately, you're just finding the first part, you're just finding the distance here and here with the information that's given. And again, I did this, so this is recorded in one of my other lectures. Number 17, they give you this function, b of t equals t squared plus 5, and they tell you to estimate from 0 to 5 in increments of 1 second. So what you're doing is you're, of course, graphing this function, and what I would do is I would plot points. So I know at 0, if I plug 0 into the function, 0 squared plus 5 gives me 5. Then it's said to do this in increments of 1. And my example said from 0 to 5, so I can stop at 5. Then I go to 1, so if I plug in 1 to my function, 1 squared is 1 plus 5. That'll be at 6. So that point's 1, 6. Of course that point's 0, 5. Then if I plug in 2, I get 2 squared, which is 4 plus 5, so that's 9. So that point's 2, 9. Then I plug in 3. 3 squared is 9 plus 5 is 14. So that becomes 3, 14. And then I plug in 4. And that becomes 16 plus 5, so 21. So 4, 21. And finally I plug in 5, so 25. 5 times 5 is 25 plus 5, which is 30. And so I get that last point, 5 and 30. So I can connect these dots, kind of, not a really good graph there, and that gives me my graph. So it says to do an overestimate. If I do right hand side, meaning that I go up to my function, the right hand side, and then I go to the left. I go up to my function and then I go to the left, and I'm just drawing these rectangles. As you can see, this would be an overestimate because I'm above the function. And so pretend I hit that point. And so what I'm finding is I'm finding the area of all of these rectangles. So how do you find areas of rectangles? You take the height times the width. So the width of each one of these is 1. So instead of doing that, I just put the 1 out front here, and then I just simply add up my y values. So which would be 6 plus 9 plus 14 plus 21 and then plus 30. to get my answer. All right, the PT12 says a car starts from rest and accelerates to 90 miles per hour in 10 seconds. So in other words, that's at 90 miles per hour, and that's at 10 seconds. And basically what I want to do is find how the distance it traveled. Well, the problem is they give me, this is in hours and this is in seconds, so I'm going to convert this, and they give you this. They say that 15 miles per hour equals 22 feet per second. So if I want to convert 90 miles per hour, I would just simply take this and multiply it by 6, because to get from 15 to 90, you'd multiply by 6, and I get 132 feet per second. So this becomes 132 feet per second. In other words, I just changed that. And now to be able to find this accumulated distance, I find it by this area, which is a triangle. So I take 1/2 the base times the height. The base is this distance, which was 10 seconds, and then the height now is 132 feet per second, and then I multiply that out and I get my answer. And that is 5.1 homework. 5.2 homework, 5.2, is they give you this integral from 0 to 12, 1 over x plus 6 dx, and they say find a left-hand sum where n equals 3. Well, remember, n is the number of rectangles. So I need to find the change in time, which is found by taking my limits of integration, 12 minus 0, divide by the number of rectangles, and that tells me the width of each one of these rectangles. So I would, didn't mean to do that. I would draw this graph out, meaning at 0, if I plug 0 into the function, I would be at that point 0, 1 over 6. I know this is the width of my interval, so my next unit is going to be at 4. And so I plug in 4, and I get 4 and 1 over 10 for my next point. And then finally, well, I guess not finally yet, I go to 8. I plug in my point, and I get 8 over 1 over 14. See, this is writing horribly. And then I go to 12 and I stop, because that told me up there to stop at 12. And so finally I get 1 over, I guess I meant to put 12, comma, and then 1 over 18. So a left-hand estimate then would be go up to the left-hand side of my rectangle, draw down to my function, left-hand side, draw down, left-hand side, and draw down. I don't go one more time because there's nothing, I can't go past there. So what I'm looking for is this area right here. And so to find that area, as you can see, I'm going to multiply 4 times, because that's all my widths. I'm going to factor out my widths. And then I'm going to just add up all of these pieces inside. So I'm going to take 1/6 plus 1/10 plus 1/14, and that would give me my area. All right, then number 3, they say my integral is from 0 to 25, and they don't give me a function, but they give me a table. So my table gives me my values of my x, which is 0, 5, 10, 15, 20, 25. So you can already see that your change in x is 5. That's my interval. From here to here is 5, here to here is 5, and so on. And then they give you these numbers, 105, 83, 68, 57, 44, and 21. And they ask you to find the best estimate, which means do a left-hand sum and a right-hand sum. And so I'm going to take both of these and multiply them by 5, my widths. So the left hand then is I take these values, so 105 plus 83 plus 68 plus 57 plus 44, and then the right hand I would take these values, so 83 plus 68 plus 57 plus 44 plus 21, and what I get, I would, these values right here that I get, I would add them together and divide by 2 to average. Alright, number 11, they give you a picture, and in this picture they have grids here, and they tell you to estimate the area. Well, all you can do is you can kind of say, well, there's one full one, 2 full ones, 3 full ones, 4 full ones, and then maybe this one and this one I would just count as a 5th full one. Okay, because I could even say, well, some of it could go in that area there. And then they also give numbers here. So this is 4, 8, 12, and goes up to 16. And even this little area here, I could have said all of that added into one piece. So what I do is I say, well, how many total grids? And let's say I have 5 times the height for my area. And so I just simply do 5 times 4. It's kind of a weird, that one's kind of a weird one. And then I have 17BC, where they give you a function 0 to 21, x squared plus 1 dx, n equals 3, and they say to do a left hand and a right hand. Remember, when you're doing these, the first thing you want to do is you want to draw this graph. So I know it's here at 1. Okay, because that's a vertical shift, or I could just say it's 0, I get 1. And then if I have 3 rectangles, that means I'm dividing 21 by 3, so that becomes 7, 14, and 21. I can get each one of these values at 7, I would plug that in, I'd get 50, so 49 plus 1, so that would be my point, 750. And then at 14, I'd get 197. So 14, 197. And then at 21, I would get 442. And then I have my horrible graph. Alright, so for a left-hand side, I would start on the left-hand side and start drawing my rectangles. And I want to find that area. For my right-hand side, then I would start on the right hand, and this would give me, pretend that dot's there, this would give me my right-hand sum. And so then I just take these and find the left hand. The width, again, is 7 times all of the heights. So this one would be, what, 150 and 197. The right-hand sum, I would actually start now here, so that would be, 7 times 50 plus 197 plus 442. Alright, then number 31, they give you a table of all of these values, t sub I and f of t sub I, and let me just write a couple of these down. And then the first thing they ask you is to give me the value of t sub 0. Well, that's just this first one. T sub 1 would just be that one. And then you do all of them. And then they ask for the value of the function at t sub 0, t sub 1. Well, that's these numbers, so 29 and 27. And then you go through and you get all those, and they say do a left-hand sum and a right-hand sum. So once again, you have your table to do your left hand and right hand. Then they change it up and say, well, now let n equal 2. So what you're going to end up doing instead of, and let me go ahead and finish this up here, you actually have 4 rectangles, because there's a rectangle from there to there, 2, 3, 4. But now they're saying I want to change it to 2, so that means your table is going to become 0 to 8 to 16. And you use the same values, so 29, 26, and 21. So that was 26 and that was 21. Guess to be complete, we can throw that one in there. And then you do the same thing, left hand, right hand sum. And then finally, the last one is they say find the area underneath this function within this interval. So if you draw this as a picture, meaning if I'm from 3 to 6, so this point right here would be at 20, be the point 3, 20, because I just simply plugged 3 in. This point up here would be at 6:38, because again I just plugged in 6, and that's my line that I want to find the area under. In other words, I want to find this area. Well, if you think about it, if you draw a line here, then you're actually getting the area of this triangle plus the area of this rectangle. Well, the area of the triangle, ooh, didn't mean to do that, is 1/2 base. Well, the base I can see from here to here is 3 times the height. Well, if I'm at 20 here and I'm going to 38, there's only 18 left. And then plus my rectangle, which is going to be the width, which is 3 times the height, and so I'm up to 20, and then you add those two together.